My name is Ryan and I am the King of Booty Fab. And today you're getting an extra video because this is not the normal project updates. Today, I'm going to take you through how I designed and built this hinge. And it's kind of complicated. Obviously, this is not a door hinge, which is what is on this truck originally. And when we needed a hinge to do this, it had to do some very specific things. But now that I've built it, I realize this is a hinge that we can use on a whole bunch of projects and probably market as soon as we get to it and get the website up and going and all that fun stuff. But I figured I want to show it off. I want to show you. I haven't done a CAD video in a very long time, so I'll tell you what, I'm going to go through this whole process, and then at the end of it, I'll show you the CAD and kind of how it worked, and that way anybody that doesn't want to watch it doesn't have to stick around. But do me a favor. If you get through this video and you enjoyed it, click the like button. If you enjoy what I'm doing, follow the channel, click the alarm bell. It'll tell you when I post a video. If you got a comment, put it down below. You got a question, put it down below. Do the whole YouTube thing. Engage with me. Ask me questions. Call me out on stuff. I love interacting with everybody. It makes my day. I love putting videos up. Yeah, just support the channel by interacting. Does good for me. But yeah, the clips have all kind of been compiled over the last couple of weeks. So if it seems a little spotty how things went, I apologize. But I'm currently filming about 5 different videos, waiting for clips to come together. And I really need to do like a script board or something. It's way beyond me. So you guys just get it raw, how it's done. But yeah, if this is something that interests you, keep watching. So that's the test cut out of 1/8 inch as it comes off the table. The final will be 3/16 with 2 1/2 inch washers sandwiched between the plates. Kind of act like bearings. We can coat them in never seize. And then I've got 1/2 inch by 1/2 inch shoulder bolts coming. And they've got a 3/8 threaded head so that we can sandwich everything tight, and you don't have to worry about over tightening these. You don't have to just send them tight. So I'm going to test fit this just with normal bolts because the new bolts aren't here, and then we can get on to the real thing.
Good, because reality TV says we have identified and it has to be done by fucking midnight because the customer's fucking coming.
Luckily we got cooler customers. I just want to get one.
Yeah, I just told him so you don't have to fucking balance everything.
Okay, so close it. That's got a stop here. It's got a hard stop right here. Like it's coming up and out, so it should clear everything back here.
Yeah.
And this is going to put the weight, you know, past the point it's going to slam shut on somebody.
Just bumper clearance on the nose.
Well, here's the thing. So
It looks like it's going to be okay though.
because we just needed to get that, we needed that triangle piece to clear, but like that comes up a fair ways. Yeah. Is what I'm thinking. Yeah, pretty much. All right, so just showing this on the sample test piece. When this is closed, you see it in the model, but this actually hits that. You can see as you come away, it separates. There we go. So that's going to hard stop there. And when it's closing, it's got a hard stop there. And then it's clearance so that it doesn't rub. And then when all these are actually shoulder bolts instead of just loosely threaded together 1/2 inch, won't be quite so wobbly. But when this opens up, so you'll watch those two plates there. Those, actually there's a burr on there. That's why. Oh, I know what I did. I extended that. Okay, so I got to knock that corner off of the final file. I knocked that corner off. This will actually sit hard on there. Yep. Alright, so the downsides of filming a week on, week off, and being back and forth, and not remembering what I filmed, and honestly, I'm back to my good phone, which I use as my camera, because it's phenomenal. But, yeah, so I got these hinges, you saw me assemble them. I got both sides done. Now I've got shoulder bolts. So basically, the shoulder bolt just means that you can tighten this thing as much as you want. This nut bottoms out at the shoulder. So I got a 1/2 inch of thickness, which means I could fit 2 pieces of 3/16 and a piece of 1/8. 3/8 plus an 1/8, go figure. And it fits, and it's actually reasonably tight. Like, it's tight enough that it shows a little bit of resistance opening and closing. Now, I can't remember if I've explained all this, so I'm going to explain it again since I've got it sitting in front of me here. Basically, the way this is designed is that when this is closed, right here, see if I can show it on the camera, right here, there's a stop. So when it's closed, this hits this, that stops it down. Not the end of the world, because that stop down would also stop when it hits the hood. But on the way out, this is set up. Oh, I guess on the way in, there's actually a stop here. I over-engineered it. Right there. So that'll hit too. So, I mean, in theory, your hood could float and it wouldn't do anything. You know, it's not like it's going to fly down. But extend it. I wanted it so that it couldn't overextend. And so what I've got is right up here. See, this is a weird shape, and it's because I wanted it to stop there. That's almost 90 degrees. It seemed like a good balancing spot. With the hinge sloppy, it kind of felt like once you got to the halfway point, it wanted to fall open. This just isn't, because there's probably a burr on the washer. I got to take this apart, and I'm going to coat the washers and the NACs and the shoulder bolts so that this slides a little bit better. Once this is worked in a little bit, it won't be quite as tight. That one maybe. Anyway. But it's all going to be bolted together, and I mean, hinges have a little bit of slop in them anyways. We don't want it perfect because there's no guarantee that that whole front clip is perfect and our mounts are perfect. And, you know, if this was absolutely perfect billet machined holes, it would probably bind up. But the way this is, this should work pretty well. So I've only got it tacked right now. And then what we've got is, for this truck, I cut these plates, and these are going to bolt in between the chrome grill pieces to the front. And then once we've got that bolted up, we're basically going to bolt the hinges down to the truck, bolt this to the clip, slide the clip into place, tack weld this to this, pull it all apart, weld it, and our clip should open and close just fine. That's the goal. That's what we're planning. Obviously, this particular video is about these hinges in general, the design and the way they go through. And, you know, I think I've got all the steps showing how it got here. But, yeah, it's pretty cool. We've already looked at a few ways. We've got another truck that we're going to build these half this size, mount it like this. We're going to build them half size, and then we're going to use them as a toe new hinge so that we can pivot it up and out of the way. Because the way this is set up, since it moves out as it moves up, we can actually mount these below floor level, open a tailgate, and have these push a bed floor up and out. We've already come up with a bunch of ways to use these in different scales, but I don't know. Never seen anybody explain how they designed one before, so here we are.
Trying to get.
I'm gonna
pull it falling off.
You just gonna pull it over? Or
Go to the back.
yeah, you guys. Okay, nice and easy. I don't know how far it's gonna go.
Fuck yeah.
How's that nose look to the front?
Still clear.
Loads of them.
Is it gonna hit us?
We need it to keep going. Yeah, right there.
That's the money shot, buddy.
That's full 90, dude. It's clear.
The stops worked.
Yeah.
Dude! Okay, it's still filming. It didn't fall off, so now I can actually look.
I'm not confident in those tacks down there that you got on these base plates.
I know,
which
I
is
only
probably-
quickly tacked it, but
Yeah.
dude, look,
Yeah, it works. We needed to cut that.
we did, but it holds itself open and the stops worked.
Yeah.
It did what it was supposed to do.
Yeah.
Why don't we get a stand under the nose and then you can get a couple more tacks on that.
On the inside?
These ones I'm worried about.
Oh, but those ones, if we're gonna build new
I
plates
know.
so they come back,
That's what I'm
then
saying. I don't want to let this.
okay,
I want to put it back
yeah.
before it crashes. Yeah.
Hold on, I got this handle.
Damn.
See, so why is that catching right there?
I don't know.
I don't know what we're running into.
Me either. One sec. So Dustin's just welding up the feet plate over there, all the actual mounting brackets. So while he's doing that, I'm just gonna grease these all up. I suggested anti-seize, he suggested grease. He's probably right. I don't know. They're probably both good. We'll wipe off the excess and paint these once they're all assembled, but greased moves good. Not greased will move better.
Yeah.
Yeah, go.
It's just hanging up.
There we go. It's one man doable, just not with my back. That's what the problem is. Hinges work though. Front still clears. Now it needs this gas strut from like here. It needs a gas strut there somewhere, somehow. So I'm a little bit rusty here, so you guys are gonna have to bear with me, and I'm gonna film from my camera because screen recording it and then trying to do a voiceover explaining what I'm doing is just a giant pain in the butt. It's about 1 o'clock in the morning, and I want to get this on the video because I think this is important and this kind of shows the mechanics behind it. Now, we've all seen hinges like this before. We've seen cars that have used them. They'll have great big springs up in here or something. But the function of this hinge is that it doesn't necessarily lift. It doesn't rotate on a single point like a normal hinge. Obviously, like I showed in the video, this hinge moves up and out. Now, in my case, let's see. We'll go back to this one. This was the original design I started with. And as you can see, when this hinge is closed, that's what it looks like. And then when it opened, this moved out and down. And that's a pretty substantial length to be moving. Now, I did this measuring this at 90 degrees of change. This was 90 degrees, and it was just an arbitrary measurement to see what the hinge did. Now, the thing is, if you were to take this entire hinge and let's say we moved any one of these points. This is, let's see. Let's say we moved this center pivot point and we're going to move it 1 inch on the model. Now these models were huge. There was absolutely no reason to build them this big. I think this model in the computer, I was just pulling numbers out of nowhere. You know, it is almost 29 inches tall in the computer. Now, I'll show you how we make this move, because this is the big reason that I wanted to get it in here. So, everything moves together, but for me, the way I did all of this is I started with one piece at a time, assuming that this bottom piece was the only thing in the entire model that didn't move. So if I take the select everything that, oops, we'll select everything that moves, and we're going to rotate it 90 degrees. Now obviously this isn't how this moves, right? So what we do is, in my case, we need to connect these 2 points. And how do you figure out where those 2 points go? Well, what we do is we make ourselves a circle that represents the arc of that. And we make ourselves a circle that represents the arc of that. And what you end up with is a point that they're going to converge on. So this one is just for the sake of, we're going to make the model look complete. We'll rotate it to there. Now this one, this one, this one, and this one, we're also going to rotate. On the center, from that center to the point they converge, and now those pieces are connected like they should be, right? Pretty straightforward so far. Okay, now this stuff quite obviously is not going to stay like that, because this point should be connected to this point. So I suppose this one, I guess I should have moved this one over to this one. Overcomplicating things here, and I'm going to move that, because we need one to stay in a fixed point for this to work. So there we go. Okay, now we know that this point is fixed, this point is fixed. We need this end here to hit that end there. So, same thing. We are going to make a circle from here out to there. We're going to make a circle from there to the center there, and we have a point where they cross right there. So we're going to rotate that. And yes, this really is this boring every single time, and you're going to see it again in a moment here when I show you what happens on this model when we move anything. This is why I saved all this for the end, so because somebody's going to get bored of it, and you know, hinges are pretty cool, and I wanted to show them off. And now you can see all those points are connected like they should. You can see the stops that I designed in the video. Now this is the hinge that I kind of originally designed, but as you can see, this was not suited to the vehicle. And this is where I was playing with. This was not the first model I designed. This probably wasn't even the 10th model I designed. I had quite a bit of time into this. Honestly, I think I guesstimated, I have in the neighborhood of 60 hours into this. Now, keeping in mind, this lower hole is now going to be our pivot hole. We just need to remember that. Now, remember, this is a 29-inch tall model. And we've moved the pivot point 1 inch. Just keep that in mind while I fix this here. So we rotated that 90 degrees still. And we're going to put a circle there. Now, if you're using SolidWorks or something like this, then you could just make things move. Rhino doesn't constrain that way, and Rhino is my weapon of choice. What do we got going on here? Delete that. I think I messed up that. Okay, we'll go back to this. There we go. This circle there. Out to there. There we go. Now, we're going to rotate all of that. We learned from the last one. So we're not going to rotate that arm because we need it to have one fixed point, and that's going to go to the intermittent spot. This is going to rotate from there to there. Now we can delete these circles. You can already see the difference here. Notice how that's not touching anymore. And I mean, on that 29-inch tall model, we now have a gap in the middle of 0.8 of an inch. Now, from here, we're going to do the exact same thing again. Going to go out to the center, and we're going to go from here to the center. And we're going to rotate that. I mean, I'm watching this video here and I already see, I've basically been walking you through this and I'm already 10 minutes in. And just into showing you this. So when you start to consider that I did, do this for 60 hours. That's about what it took. Now ignore these 2 points because these 2 points are where they would have been. We changed the pivot point to there. But that is a direct side-by-side comparison. And if we're just looking at a vertical height, change the difference on a 29-inch tall model by 1.8 inches. $25.65. To 24.31. So that's on a 29-inch tall model, and it moved it inches up, down. It changed the angle. It changed everything. Now, I did this for hours, and I beat myself up. Because as you can see, I was imagining this is the hood. This is my mounting spots. You'll also, if you're paying attention, notice that this doesn't quite look like what we have in the truck at the beginning of the video. Because This is the model I originally designed that stood up. What we ended up with in the truck was this, which is this model flipped that side down. And the reason it looks like it's not just rotated down is it's mirrored, but this is the exact same model. I was just looking at it the wrong way. I had it all figured out. I just didn't know it. This is the model I designed. This is what ended up going into the truck. And in the final design, this bar ended up bent because we needed clearance for the cross member. Now this was the design that lifted up and out the approximate distances I want. I could have gotten this to move further out. I could have gotten it to move further up. I could have, shoulda, woulda, coulda. Now, I have CAD here, so I can actually see all of this. I changed the shape. I didn't want to go a full 90. I believe this is 80 degrees. Something like that. What did we go out to? I'll tell you before I... Let's see what angle I went out to. Angle... I went out to 80 degrees. So I didn't really want to go out 80. There was reasons behind that. The weight, the need, it's a lot of weight in my case. And I found that, honestly, that was more than enough. Now, having CAD, I can see it in 3 dimensions. I can see how things are going to fit. Build my plates. But if somebody wanted to do this, you could quite literally take a piece of cardboard and you take some graph paper, tape some graph paper to a piece of cardboard, and then you'd have you get your grid papers and you count every dot as, say, an inch or a half an inch. And you could basically build arms out of toothpicks or other pieces of cardboard and pin spots. You pin these, you pin those, and cycle it with pins. I've seen it done with suspensions before. I've seen it done with something similar to this. There's ways to model it. If you put basically thumbtacks through pieces of cardboard from the bottom and put it on your table, you could move it in and out the way I was on the truck. You do not need CAD to design this. It just helps. And honestly, if the software that I preferred to use had constrainable movement, I'd be so much happier, but I have no interest in buying SolidWorks as well as Rhino. I don't use it enough. It's just not for me. But in my case, when I originally designed all of these, I seem to have deleted all the old files, but you can see, this plate didn't end up flat. It ended up radiused out. This plate still ended up like this, but it was smaller around the end because otherwise this would rub. These plates here were basically over and then bent down. This addition and that getting fatter was purely because I wanted a hard stop. That is the hood open stop. Not on that one. It is on that one, but wrong way. You know what I mean? It's this is my hard stop. So I redesigned it, and that was the beauty of having the CAD software. But these were designed for a project, and I don't even know if any of this helps somebody. I hope it does. I hope it inspires somebody. I'm not sure what I hope. I'm pretty proud of these, though. This is about 60 hours of my time to design these and put them together. I'm going to end up making them again. We're going to end up marketing them at some point. But I've got a whole lot of products I've designed over the years that it'll get there eventually. For now, yeah, for now, this is the CAD work. And I hope you enjoyed your quick and dirty delve into the computer work behind the video. Well, there we go. I hope that's all the information everybody needed. I hope that shows what we had, shows what we go through, gives you guys some ideas to build some stuff on your own. You could do all the stuff that I did on the computer. You could also grab some cardboard, some pins. You can grid paper. There's a lot of ways you can do it. I think I mentioned it in the CAD stuff, but you know, there are ways to do this outside of CAD. The CAD just makes my life easier. But I hope it inspires somebody. I hope you guys enjoyed this. If you did, like the video, follow the channel, click the alarm bell, you know, interact with me, drop me a comment, tell me what you think, do the whole YouTube thing. And this time, I'll see you guys tomorrow because I'm posting another update about this truck. So this just needs to get out first. Thanks for tuning in, guys. It's really late. Sorry I'm rambling. I've been out here a really long time tonight. I've been in the shop for 15 hours today, and I'll probably be out here in less than 8 hours again. So thanks for tuning in. See you next time.